Welcome, friends. My name is Vivek Prakash, and I welcome you all along with my colleagues and the presenters for this Project Managers Club of Pune's webinar and of month September. We are doing this program for building a community of the project managers and share thoughts across the industry, learn from each other, learn from the success of each other, learn from the failure of each other, and overall the experience of each other. So we try to bring these seminars and webinars, so sometimes physical and sometimes online, depending upon what is more feasible and more conducive for the participant. And looking at the season and things, we thought okay, a couple of sessions let's have online, so it becomes convenient for the participants. Also, people from outside of Pune should join this. So we are doing it online, and maybe we'll bring in maybe month or two we'll bring the classroom as well, the physical one, and we will try that if we can bring in hybrid one, so that the people at online or in person both can join actually, and with equal effectiveness. So thank you very much to all of you for this patronage and you taking out time and joining this webinars. And today's topic is digital twins. So probably many of you might be, for you, this will be a very new term and might have not heard about it. And but this is some kind of like a simulation, very effective techniques, which has been like changing things have been coming. And we have two experts here who have been like hands-on on these things, and they will explain you some critical path project management, critical chain project management, and also the digital twin, that how effectively it can be utilized to improve the project results. So I have Aniruddha and his colleague Shubham. So I just give you a little idea about what Aniruddha and his colleagues are. So Aniruddha is actually a co-founder and director of Yagna Entrepreneur Success Services. He has over 25 years of experience and in the various segment in various industries, Indian and MNC companies and Indian and MNC clients as such, right? For last 14 years, he's promoting this organization called Yagna Entrepreneurs, and he's certified in critical chain, theory of constraint, and critical chain project management is part of it. So he's a very expert of that also, and has been implementing this in many organizations. And here he will not only explain you some part of critical chain project management, but also will demonstrate you digital twin and how it can affect, like improve the project results and how you can apply this and this. So over to you, Aniruddha, for this session, and please come over here. Welcome.
Thank you so much, Vivekji. And thank you to you and the PM Club for providing this forum. Hopefully, I'm audible.
Yes,
I
very
think
much.
this kind of forums, I think, help us, practitioners like me and Shubham, to spread awareness about the work we are doing and the new developments which are happening in the field of operations, whether it is production or project management. And so thank you for this. Now, the way we have, so I'll just fire up the presentation. The only thing is, I'm based out of Pune. Currently, in my area, there has been heavy rain, so
Yeah.
I just hope the power and the bandwidth signal holds up. So maybe from time to time, I might just switch off the video, just to
Okay.
make sure that there is no disturbance in the bandwidth. In terms of the interactivity or interactions, I'm happy. Same for Shubham. If you feel that there is some burning question which has to get answered at the time I'm talking, so please stop me. Happy to do that, because it's not about just me and Shubham just throwing a lot of stuff at you. Uh, Ultimate idea is that you become aware and then in future benefit from these concepts. So do stop us anyway. Some logical points in our discussion over the next 90 minutes or so, or 120 minutes. We will pause and then we can have a discussion. So let me with that just
So let me also add into this. So during this presentation, anytime you have any question, etc., please feel free to put those questions in the chat. We will be looking at it and getting in a proper opportunity. Will ask the Aniruddha to address that.
so hopefully you can see my slide which I have
Yes.
shared. So I'm just going to switch off the video for a while. I can switch it on. No problem. So the topic today is digital twin in project management. Now, this digital twin as a concept, you can equate it with what is popularly known as simulation or dynamic simulation. So that is going to be our main focus in this discussion over the next few minutes. But as a build up to that, we need to talk about critical chain. We need to talk about what are the problems which are there in project management, which we have observed. That's been our experience. I'm sure all of us who are on the call have project management experience. So, Vivekji, I don't know if you are going to be able to do those polls which I mentioned
Yes, should be
at the
able to. You want to launch it now?
yeah, so maybe I'll just take couple of minutes to go, just talk about this slide and possibly the next one. And
Yeah,
then if we can have the poll, so that
sure,
will just give us an idea about the profile of the participants. So
sure.
we can accordingly talk about our
Yeah.
concepts. So just you might see this on the right hand side. I think most of us would have probably come across this picture of the old lady and the young lady, right? So if you see in this picture, if you look at it one way, there is an old lady, and another way, if you look at it, there is a young lady, right? The only reason for putting up this kind of picture right in the beginning is just to request you, persuade you that all of us are experts in project management. I'm sure you must have been practicing project management, different methodologies, concepts, principles, tools. You might just want to keep an open mind here to look at this what we are sharing through critical chain and digital twin. That there is possibly another way, a different way to manage projects and to get results, right? So that's the only reason I put up this old lady, new lady, young lady, that you might be doing things in a particular way, but there is another perspective which you might just want to consider and evaluate as we go along. Hmm. So having said that, I'll just quickly go to the next slide and then we can fire up the poll. So the first and the last bullet points are the starting and closing poll. But the main three topics what we are going to cover is just quickly talk about what are the problems in meeting the project OTIF, as I'm calling it, on time, in full. And in full means that we are doing it with the scope what we have agreed with the client, or if it's an internal project, then with our management or whoever is sponsoring it, and within the cost or budget. That is a very important thing in projects. And then we will share our experience of how CCPM helps in addressing these problems, and we'll do it through two small exercises. Because this is an online session, we'll probably not be able to do it with you, as in I will just share what that exercise is. I'll request you that when you go back after this tomorrow, whenever next week, you could actually do this exercise with your team. So whatever slide or whatever is required, I'm happy to share that. But in this session, I will actually take you through the exercise. You will not be able to actually do it because it's in an online mode. And then coming to our digital twin, right, saying that because CCPM or any other methodology for that matter has got many different aspects, many different rules or many different concepts. What digital twin helps us to do is for a specific company or specific set of projects, what are the kind of rules which are actually bringing about the improvement which is desired, right? So as we go into that topic, we'll discuss in more detail. So we have some set of projects from our twin. which we will use for this particular session, right? And then we'll end off with a poll just to get an idea, that some kind of a feedback for me and Shubham, to see how well we were able to communicate to you through the online medium. So that is the way we have laid this out. So Vivekji, would you want to just
Should I launch the first poll?
yeah, please, if you can. I think the first set of, I think, questions which are there. Yeah.
So we request people to choose your option.
Okay. So I,
Yeah,
I think
maybe another few seconds, I will just close it.
sure.
So if
Uh,
just give it 10 seconds to the people who have just want to do it and not done it so far.
yeah. And then do you also have the other set of questions also lined up? Can we have that?
Yeah, yeah. So let me end this and
Yeah.
so let me close this. Okay, and the you want me to the put the other poll also?
Yeah, the other four questions, I think, which, if you have it, we can quickly go through them. Yeah.
Acha, all polls are meant in the beginning itself, one after another.
There are some in another tab I have given you questions for the closing one.
Okay,
But these are the five questions which we have at the right in the beginning.
okay, okay, okay.
Yeah. And the only idea, friends who are on the webinar, is just to get an idea of the
Yeah, the audience.
participants,
Yeah,
audience, so
yeah,
that
so that you can adjust the
correct,
discussion accordingly. Yeah, that's good
correct.
idea actually.
Okay. So I think we have
Okay, I give you 10 more seconds. Anybody want to respond? Please do respond. Okay, let me close this. Should I launch the third one?
please. Okay.
Okay, so let me take 10 more seconds to close this.
Sure.
So you need to explain it because most of the people have either heard it or not at all.
Yes.
Okay, and you have now the fourth poll, right?
Yes. Okay. So there's one person who's actually applied it. That's good. Okay, so this is not surprising because digital twin, anyways, as a technology is relatively new,
Yeah.
and
And not many people are involved in simulations because it's generally required, say, quite a good amount of work actually.
yes, yes, absolutely.
So it may not be always easy. So let me close this poll first, and then the fifth one also you want me to launch?
Yes, please.
Okay.
Yeah, this is the last one. What the
Yeah. It is the biggest one, right? Where people have to think little bit, right?
so
Others
we
are
can,
not, the others are fact actually, right? Either you know
yeah,
or you don't know.
very true, very true.
Yeah. Here you have to give a little stress to your mind, okay?
Yes.
So as I see it, resource conflict is quite common, I think, which
Yes,
is as expected, and then meeting deadline,
yes. So,
and then the scope and budgets. And tracking is not that a great, or not, people don't think that is a main thing.
yes,
Ultimately, it is resource conflict and meeting deadline. Okay, let me close
yeah,
this.
fair, good. I think thank you for the responses which we got. Okay, so let me go back now to the. I think we have some idea now of the profile and awareness about TOC, CCPM, digital twin, and the biggest project challenge. So that's good. So let's quickly start with our first section, which is about the problems in meeting the project. So again, I think I'll not spend a whole lot of time on this because I think most of us I think are working in project environment, and even though the projects may be different, whether it's a software project or it's a R&D project, or whether it's actually making a film is also like a project, a feature film, the problems somehow seem to be more or less the same. So if you look at it now, the projects is a complex and challenging environment, right? Because we've got on, so it's like a very difficult balancing act, because you've got, first of all, these three things to meet. You've got the time and the schedule. On the other side, you've got costs and you've got quality and scope, right? So these are like the three legs of the project stool, and this has to be now balanced, and a project has to be balanced on the fact that you have this reality, a bumpy road of reality, as we call it, that you've got some kind of a structure. Every project has some kind of a project network or a project plan where you have set of tasks which have dependencies, right? You can't do task B before task A, right? Task A has to be completed, only then I can do task B, and so on and so forth. There is statistical variation, and we'll talk about it a little bit henceforth. So this is very much prevalent in projects, unlike production where the statistical variation or the uncertainty is much lesser compared to what we find in projects. And third very important bit is that in projects, humans or people play a significant role, right? So I'm just going to keep on contrasting it with production because I have got some amount of experience in production and projects kind of part of operations as an overall topic. So compared to production, you find that a lot of the work in projects still actually gets done by people. A lot of knowledge work is involved in projects, whether it is design or development and so on, compared to production. And that's what brings it that additional challenge, right? Because you've got people involved, and when people are involved, and unlike machines, right, people have their own nuances which you need to cater to. And just to top it up, in addition to this, what you find is that projects also become challenging because they're spanning over longer time horizon. A project, say for example, if you're setting up a huge plant, a power plant or something like that, it could probably run into months, if not years. But a typical project you will find spans over a much longer time frame than a typical production job. The other bit is connected to the fact that people are involved, means that you have, out of the total lead time of the project, you will typically find that the touch time, the actual time, call it the process time, is actually much higher as part of the lead time, right? In production, you will typically find that if I'm quoting a 4 weeks lead time, my actual process time or touch time is probably not more than a day or two, or maybe a shift or a couple of shifts. The rest of the time, actually, the job or the order is waiting somewhere, either in backlog or somewhere in queue or whatever it is. But in projects, you will find that the actual time to do the work is far more as a percentage of the overall lead time. And then, as we said, there are multiple paths, tasks, depending on the kind of project you have. The number of tasks could go into thousands if it's a huge project. And that means that actually holding the integrity of that project plan over a period of time is a major challenge. And the fourth thing, very importantly, is there is a huge amount of uncertainty because we might have done a similar project, but we have not done the same project, and that is why it is a project, right? Because we have not done the exact same thing previously. There is some amount of uncertainty, some amount of difference which is there. In maybe real estate projects, the uncertainty level in terms of actually constructing the house may not be so much, but an R&D project could have huge amount of uncertainty because I've never done that kind of thing or that product earlier. Right. So the level of uncertainty could vary from project to project, but this is a very typical characteristic of a project, which makes it extremely challenging, right? To balance this whole thing about time, quality, scope, cost, all of this makes it highly challenging. Right. And then typically what you find is that these are the typical challenges what you find on a day-to-day basis when you are in a project environment. So one is the time, scope, cost, which we talked about, the fact that resources are not available when required. So I think there's a high percentage of our friends on the webinar saying that resource conflicts is a big issue. So there are conflicting requirements for resources. They're getting pulled in different directions. Client requirements keep changing, right? Because the client himself at times in certain projects is not very clear on what really is the deliverable he's looking for. He has some broad idea, but he doesn't have a clear idea of what really the deliverable looks like. Unlike a production environment where the bill of material and the engineering spec and all fairly crystallize what really the client wants. That is not the case in many of the projects. And then we've got many projects open at the same time, constant tug of war over time estimates. So we'll talk about this, how critical chain actually addresses this in some ways. Repeated rescheduling of the project. I think there's a bit of a typo in couple of the sentences. So it's repeated rescheduling of the project happens, and then uh, clarity at the start and end, right? So when the project starts, there is a project plan. Everybody gets into a room, makes a project plan, and uses some kind of a tool, whether it is a Microsoft project or some other software. Uh, and but then as things move forward in the project, depending on especially the tenure of the project, things become very hazy, right? So I'm just calling it a thick fog in between. You're not very clear on really what is happening with the project, whether the project is actually moving as per the timelines or is it going to get delayed? What task is really actually holding things up? That clarity is not there at an overall level. Maybe individual folks are aware, but and then when the project comes towards the end, then of course all hell breaks loose because there's a lot of shouting and screaming, and then everybody focuses and somehow gets the project done. Right? That's the typical nature of how projects happen, and that is the reason because we don't have this clarity throughout the project. So either we intervene too much too early, or typically what happens is it's too late, right? So either if the number of projects are less, or maybe because of the criticality of the project or whatever, we end up either intervening too much, or in many cases, because we don't have this clarity of how the projects are progressing, we actually end up intervening too little, too late, and that's why you find that the reality is that most projects actually end up late, right? And then the team, of course, has to make up by working for extras during the fag end of the project. So that is the typical challenges what we find in the project environment. Again, as I said, cutting across different types of projects, uh, more or less these issues are there, and that's why you find that actually a project getting completed on time becomes a news. If it's a government level project, then it comes up in the papers. If it's a company level project, then it gets highly celebrated that we could actually get something out on time, what we had committed, right? So now it's not that people are sitting idle and not making an attempt. I'm sure there are a lot of approaches, a lot of steps being taken, a lot of different methodologies are there to improve these outcomes, because everybody is looking for improving these outcomes. And what we have seen is typically what companies and groups try and do is they focus a lot on trying to reduce this uncertainty which is embedded in the project environment. So the whole focus is somehow can I impose some kind of certainty on an inherently uncertain environment. So maybe the things are I do a very detailed upfront planning, because in a project you will, or any operations you find there is a planning stage, there is an execution stage, and then there is an improvement stage. So we will use this construct of planning, execution, and improvement even when we talk about CCPM and the digital twin. So coming to the planning, there is a huge effort to somehow do a very detailed plan, because the assumption is that if we are able to somehow detail out everything upfront, that will help us to kind of get a little bit of control on the uncertainty and the Murphys, and then that will help us to deliver projects on time. It unfortunately in many cases doesn't work out, because being an uncertain environment, how much ever detailed planning you do at the front end, when the plans hit the reality and the Murphy, many of those plans go awry. Right. So again, we'll share with you in our critical chain method what kind of planning do we do, what we call as the good enough planning. Then there is very close tracking of the efficiency and the utilization of each resource. We do frequent status reviews and reports, right? There's a buffering which happens through some kind of capacity and contingency padding, automation and tools, right? So we know, I mean, we are in the world of age of AI, and also huge amount of automation and digital tools are used across the project spectrum to see somehow can we get control on the projects. And then there is a siloed accountability which comes in, saying every person is responsible for his or her task, to make, because the assumption is that if I'm able to finish every task on time, then my projects will get finished on time, right? So there is that local accountability, local optima, because that is the whole thinking, that if we are able to do this, we'll be able to finish the projects on time. But typically, at least our experience has been, and I think we'll be happy to hear views later on, whether you believe that this kind of an approach has helped you in your project environment to get that time, scope, budget results. Right? So this is the typical traditional approaches to project improvement. So now I'll switch to CCPM. So any comments, any thoughts so far? Anybody would like to express? Am I audible?
Yeah, you are audible.
Okay,
I
fair
think
enough.
so far it's quite common as such,
Yeah,
probably.
it's common. Fair enough. Yeah,
Yeah.
so we'll just crack on.
Yeah.
So now we will share in about 15 minutes to half an hour or so on this whole methodology called critical chain project management, which is part of the body of knowledge of what is popularly known as theory of constraints. So again, I don't want to dwell too much on TOC as a topic, or but just to be brief. So theory of constraints was developed by a physicist, uh, Dr. Eliyahu Goldratt, and his working tenure was from around 1978-79 till about 2011, when he unfortunately passed away. And during this period of around 30 odd years, he actually created a complete knowledge base for all the areas which you will typically find in a company. So he started his journey with production by the classical book, The Goal. I don't know how many of us on this call have read. If not, I would highly recommend that you read the book, The Goal, which is a classic in any operations area. So production, then he moved to project management, and then there was decision making, what we call management accounting, marketing, sales. thinking processes, strategy, right? So there is a complete suite of principles and processes and applications for each of the areas, what you typically find in a for-profit company. Of course, this TOC has also been applied to areas like healthcare and education and NGOs, right, for-purpose organizations. So it's an extremely powerful methodology adopted, worldwide, in India, outside India, whichever way you slice and cut the companies or organizations, you will find that TOC or one application of TOC has been adopted by every organization or most organizations across or the big organizations across the world, right? So CCPM is part of that, and CCPM pertains to the topic on hand, which is the project management, right? So just to keep it now simple, the way to look at say our project management problem and project management solution is that, see, the goal. So maybe let me just first explain. Can I bring up the annotation? It'll help me to focus. So if you see this column, what I have put, the 1, 2, 3, 4, 5 are essentially the what we call as the generic focusing cycle of TOC. So these are the 5 steps which help us to make an improvement in any particular area, right? So this is a generic 5 step approach which I'm sharing, and then I will apply it to the projects environment, right? So the generic focusing cycle starts with understanding what is the goal. Because if you don't know what is the goal, what is it that you're trying to accomplish, then right, everything and anything is meaningless. But generally, we know what is the goal. So the second step then is that we need to figure out that what is the constraint which is preventing the organization from achieving the goal. So, and here constraint has a very specific meaning. So constraint could either be, let's say, demand, that I don't have enough orders, or it could be capacity, that I have demand, I have orders, but I don't have enough internal capacity, or my supplier doesn't have enough capacity to deliver. Third, it could be cash, that okay, I have demand, I have capacity, but somehow I am in a cash constraint kind of a situation. And in the context of project, it also means the total time which I have available for delivering the project. So we will come to that when we talk about the project specific thing. So this is what is the meaning of constraint in the context of TOC. It is not the generic usage of the word constraint, where we say, I have 1,000 constraints in my company, which we normally use in the with the indication that it's like a problem. So constraint here is not a problem. Problem comes as a third step. Constraint has a very specific meaning, right? So when you go to the third step, then what you're saying is, what are the major problems which are preventing the organization from getting most out of the constraint, right? Because typically what you will find is, the 99% of the companies, you will find that because there's no understanding of the concept of constraint. So what happens is, there is a huge wastage of the constraint which happens. So whether it is, for example, if you take in a production environment, maybe simpler to understand right now, that you have a machine which is popularly called as the bottleneck, or a constraint as we are saying it. Right, if you don't have that perspective that this is the machine which is actually deciding the output of my plant, you will find that all your policies and a way of working for that machine is the same as any other machine, and which will mean that you will find that there's a lot of wastage of the capacity, right? So what this step forces us to do is to specifically list down what are the major problems because of which I'm not able to get more of the constraint, and it is leading to wastage, right? Then the fourth step is, we actually then figure out that is there any kind of a conflict or a dilemma which is preventing me from resolving that problem. Because generally in organizations, again, very experienced, very knowledgeable people are working. So if it was something very straightforward, the assumption is that problem would have got solved, right? So, many times what happens is, people are aware of the problem, but they are caught in some kind of a conflict. Should I do this? Should I do that? So, for example, a classical one which we find in, say, production is, should I hold high inventory or should I hold minimal inventory? Right? I want to hold high inventory because I want to protect availability or sales. But as soon as I hold high inventory, I'm jeopardizing my working capital or cost or whatever it is. And so there is a pressure from finance or senior management that don't hold high inventory, right? So now, should I hold high inventory? Should I hold minimal inventory? What do I do? And organizations are not able to come up with a win-win resolution of the problem, and then that prevents you from having to live with that problem, right? And then the fifth step is actually to come out with an innovative solution based on the TOC concepts, principles, applications which are there. Because TOC solutions are all about creating win-win solutions, right? There's no compromise. We always come up with a win-win solution because that is the only one which sustains and which gives you phenomenal results. Right? So that is a typical 5-step generic focusing cycle which we use. Now, if we come to projects, let's say I've said that the goal of the projects is we want uh, good outcomes in terms of, let's say, time. Out of the time, scope, and cost, I'm just taking time for the moment. That I want to deliver projects fast and on time, because in most environments, doing that will kind of, in fact, even establish some kind of an edge in the market for me. So that's a goal, it's a valuable goal if I can achieve it. The constraint now in this particular case is, the way we have to understand it is that if any project plan or project network, I'm sure all of us will be able to relate to that, that it will have what we call typically in a non-TOC terminology, we call it the critical path, right? Which is the longest path of dependent tasks or dependent steps, right? And then there is also the feeding path. There will be a critical path, and there will be certain set of tasks which will feed into the critical path, and the time on that critical path, or the tasks which make up that critical path, they are in a sense the constraint, right? Because any delay which happens on that path will mean that the project will get delayed. So if on the feeding path there are some delays, I'm still okay because I have some slack. But if I delay on the critical path, or as we call it in TOC, critical chain, why we call it chain and not path, we'll come to that. Shubham also has one slide on that. So we'll talk about it. But the main point being that any wastage on this will lead to will lead to your goal not getting accomplished. Right. So we'll have to see what I'm going to share with you now in the next 2-3 slides is what are the main reasons why time gets wasted on the critical path, right? And how CCPM attempts to reduce that or overcome that, right? Another thing I want you to be aware is we'll be using this terminology, especially when we get to the digital twin, where we say that the total time of a particular job or a project remaining in the system as in when it is under execution, is you can look at it from three parts. Right? One is time in backlog. So where we have actually got a project, but we have decided not to start it for whatever reasons. It's in backlog. Then there is time in queue. So when actually the tasks or the phase for a project are released, right? But it is in queue, it is waiting because maybe we don't have the full kit or we don't have the resources, whatever be the reason. So it's actually waiting. And then there is actually time in process, right? When actually the work is happening. So short form point of view, TIB, time in backlog, TIQ, time in queue, TIP, time in process. So these are the three main components of the overall lead time of a particular project, uh, from the time it is received till the time it is closed out. Okay, so this is what now we have to see. So we don't want to focus on anything else. We just have to focus on identifying what are the major problems which are leading to wastage on of the time on the critical path. Right. So now I'll quickly go into two parts. So let me just take this out. Yeah. So now I want to share with you two things. How are we doing for time? Okay, 46. Uh, so as I said in our work, we look at any operation solution from the point of view of planning, execution, and improvement. Right? There are certain things which you do in planning, certain things which we do in execution is in project execution, and then we try to improve this whole process. So normally if it's an in-person webinar or in-person session, we actually do these exercises with the participants. But as I said right in the beginning, I think in an online session, it kind of becomes difficult to conduct this when you have almost 50 of us on the call. So I'm just going to take you through, and hopefully you'll be able to appreciate what I'm saying. So what we'll in fact do is we'll start first with the with what we call as a multitasking game or an exercise, which is more on the execution side, and then we'll come to the sixes game, which is on the planning side. Right? Again, just to be clear, what we are trying to figure out is, or the hypothesis we have is that there is a significant amount of time which is wasted on the critical path, because the focus now has to be on the critical path. A significant amount of time is wasted because of the way we are doing the planning and execution of the projects. Right? That is the hypothesis we have. And that is what I first want to share it with you through the slides, and then we'll get into the digital twin. So now this the way. So far, are things clear? In any observation, comments you want to make before I get into this exercise or the game? Uh, is my voice coming through? Okay, are you able to understand what I'm saying?
Yes. To me, it is good.
Okay, fair enough. So anybody else wants to speak up, do it at any point of time. I'll just continue. So in this now, what we have set up is, so right, any game or exercise is more to bring in some kind of experiential learning, kind of, from that approach. So what we normally do when we are in an in-person kind of a session is, we say now we have got three projects. Right? So we've got three projects: Project Red, Project Blue, Project Green. And what you see on the left side are essentially the tasks which you have to complete as part of the project. And because this is a simple exercise, obviously the tasks which you have to complete here are fairly simple, right? That in Project Red, essentially a task means you have to just write down the numbers from 1 to 26. Just write down 1, 2, 3, 4, 5, 6, whatever. Project Blue involves tasks in terms of writing the alphabets A, B, C, D right up to Z. Project Green is little more tricky, as in there are some symbols which you have to write at the rate and percentage and hash and so on and so forth. And then there's a sequence in which you have to write, which we normally give out to the participants. Right. So this is now these are the three projects. Now the point is that the way this company operates, or the way the projects are handled in this particular company, is the philosophy is that we need to show progress on multiple projects at the same time. Correct. So this is the way we operate. This is our operating environment or operating condition. And what we then create in this exercise is that there are interruptions, there are stoppages, there are projects which have to be paused. So let's say if one of us is a resource who has to work on all these three projects individually, what happens is, wherever you find that you have this stop as marked here, the idea is that we need to move from this particular project blue. Wherever I find stop, I need to go into project red. I start working on project red. Then again, I find that there is some interruption. Maybe the project green manager has now called me. The resource manager has called me, or project manager has called me and said, please, pause whatever you're doing. Please move on to project green, and you start working on that. As soon as I progress for some length of time, again, I get a hit saying that no, you need to go back and show progress on project blue. So I continue working on EFG. Again, I get an interruption, so on and so forth. Right? So what we're essentially trying to do is trying to mimic in some way the reality of how projects get executed in a real scenario where there is some kind of start stop which is happening. Okay? So that's what we are trying to mimic through this exercise. Now, what happens here is, if you see, there are in a way 26 into 3, so roughly around 78 tasks, if you take up all the three projects. And given the simplicity, or the pretty straightforward nature of the tasks, you should actually be able to do all of these tasks, say not more than 35 to 40 seconds, right? Half a second for writing one particular character is par for the course. But we say, okay, let us have equal amount of buffer. So what we are expecting is that you will be able to complete this all the three projects in around 80 seconds or so, right? 26 into 3. So we gave 78 seconds. We say, okay, let's take 1 second per task or per character, and you should be able to do it in 80 seconds. In reality, what happens is because you have this switching which happens, and because you have these interruptions, three things happen, right? As probably most of us will be able to visualize. One is the total amount of time which is taken to complete the three projects. It clearly expands, right? So generally, what we have found in workshops is that these three projects take anywhere between, say, 120, 130 seconds, could go all the way up to, for some participants, it could go all the way up to 180, 200 seconds, depending upon their understanding or whatever is there, right? So that is the kind of range. So first of all, you find that overall portfolio duration of, if you say these three projects form a portfolio, you will find that it just expands, right? Second thing which happens very clearly is that now you will find that all the three projects are more or less starting at around the same time, right? Because everywhere the way we have configured it is that just after four tasks, you have to move to red. After another four tasks, you have to move to green. So in a very narrow time range, you will find all the projects are starting. And also you will find that all the projects are actually getting completed also in a narrow time range, right? Because you're trying to progress on each of the projects, and you will find that at the end of, say, 130, 150 seconds, whatever that time range, you will find in a matter of another time range of 5 seconds, all of these projects will finish, right? So all these three projects are open for that period of time, and which means that, say, practically, from talking from an implication of the of a project revenue or budgets and stuff like that, you will find that all of your revenue accrual happens probably, gets lumped up, gets batched up towards a particular time frame. Whereas ideally, you should have had projects getting completed and revenue coming into the company regularly. That doesn't happen. The third important thing what we observe in workshops, what happens is that the quality suffers quite a lot, because as you are switching from one project to the other, you find that there are mistakes which are happening under time pressure, because you're not able to focus and concentrate on one particular project. So you keep switching, and then you find that there is at least a 20-30%. It could, in some cases, it could be as high as 50%, where people are making mistakes, right? They forget that they have to actually continue from, say, D to E. After they've come back to blue, they will again write A, or right, they will mess up the kind of numbers and characters and stuff like that. So a lot of quality issues crop up, and that's what we have seen in the real environment as well. That a lot of the times what you find is that what looks like a quality issue is actually nothing to do with the fact that either the people are not trained or anything like that. It's just that we have put them in this kind of an environment of what we call as multitasking, where many projects and many tasks are open, and they have to keep on switching, which leads to quality and mistakes, right? So these are the three typical undesirable effects or problems which we find when you operate in this particular environment. And what our experience is that what we are playing, we play this in two rounds. So the first round, what I described to you over the last 5 minutes, is typically what we have found in companies. This is the way the work happens, right? And then when we switch to round two, in round two, what we are essentially doing is we are now saying to people that, okay, if we have to change one thing, right? We just have to change one thing here, some kind of a policy or a rule. If you have to change, what would that be, so that we are able to get faster completion, which is our goal. We want to complete projects faster. We want to complete projects regularly. We don't want this kind of batching of the projects. We want regularly, so that our financial health is also better. And third thing is our quality also improves dramatically, right? So what is that rule or policy I should change, so that all these three are achieved? Yeah. And again, we could have had a discussion if we were in the physical environment in person. But right now, I'm just sharing with you, which might seem pretty obvious to some of us, that the only rule we need to now put in place is that we need to focus and finish, right? That when we take up one particular project, say project blue to start with, we will not switch to project red till I have completed fully all the tasks of project blue, right? In when we do this as an exercise, each of us are doing it separately. So I am the resource who is doing all of these three. In a practical environment, you need to do the translation for what this means of focus and finish. But the rule is that I will not do negative or bad multitasking, as in I will not switch from one to the other just to show that I am making a progress. Ideally, I want that once I pick up a particular project or a phase of a project, I will work on it fully completed, and only then I will move to the next one. Okay? So that is the rule which we need to put in place. So we'll see also interestingly the implication of this when we do the digital twin, what kind of results come out. And what you find in the context of this game is, I think most of us will be able to predict. Obviously, the time goes down dramatically. So instead of that 120, 150 seconds kind of a range, you will find that typically projects get completed in anywhere around 40, 50 seconds, right? Because now people are just focusing on that one project and fully completing it, then moving to the next one. So each of the project takes anywhere between 10, 15 seconds, right? And you finish off everything in about 45, 50 seconds, give or take a little bit. So what that means is it just shows that, within that same now time frame of say 120, 150 seconds, which earlier we experienced, we could do many more projects. And of course, the quality improves and the things were talked about, right? So that's a simple change in the policy and the rule which we need to adopt, uh, right? So we have not made any new investment. It's the same set of people, same project, same infra, everything is the same. What we are doing is we're slightly changing the way we work on the execution side, and that brings about a good amount of results. Of course, the fact is what I'm sharing with you only right now is a principle. For every project environment, for every company, the translation of this has to be done in a proper way. And that's where practitioners and consultants like me and Shubham come into picture. Right. So any thoughts on this? Any questions? I'm just going to quickly also show you what we do as a small cause and effect tree, right? That what is really happening. So I'll just bring this up quickly. I think I'll just take another 10 minutes and then we'll switch to digital twin. So if you see what is happening here is what I shared with you is there's a constant switching which is happening between tasks. Now, really, why is that happening? Right. So when I said that we have to change this policy and rule, actually there is a lower level to that, because the reason why that happens is we as managers or senior professionals, we actually set certain policies, and the policies which we set is, or the lack of it is, if for example we don't have any concept of a full kit. So if you don't have a concept of full kit, what happens is people start working on a particular task, and then they find that okay, they get stuck in between because now they don't have all the input data to complete that particular task. And then they will say, okay, I have to keep that aside, and I will move to another task or another phase of a project, because I've got something there to work on. Because the other thing which drives this behavior is that we want to show progress on all the projects, and very importantly, I want to I'm measuring the local efficiency, right? I don't want to sit idle, because it will go into my timesheet that, for example, this XYZ person did not have work to do for X amount of hours in a week, and that will not show up very nicely when I have my appraisal with my boss, right? So I need to show that I am constantly working 8 hours, 10 hours a day, whatever has been allocated. So this kind of measurement, coupled with the fact that there is no concept of full kit, again, also there is not, let me just bring up this annotation so that I can, yeah. So if you see this priority, a single priority mechanism is absent in companies, and we don't have full kit, and then there's an expectation. So all of this means that what happens is this leads to actually the constant switching. So we have many half completed open tasks, and which leads to what I spoke about, right? Quality, touch time, wait time, workflows, and then that overall culminates into a higher lead time, which is completely opposite of the goal which we are trying to achieve. So this is what we have experienced, and this is what comes from the TOC body of knowledge, that this is the first thing we need to recognize, right? This whole negative multitasking which is there, we have to create some kind of antidotes for this and put in place policy so that this doesn't happen. So I'll go off to the next one now. Now we'll go to the planning part. Okay, and then maybe I'll stop and we can talk about this for 5 minutes and then move to the digital twin. So this is now what we call as a sixes game, right? So now we're talking about planning. So again, planning and execution. We saw what happens in execution if you get into this multitasking, negative multitasking mode, what happens to your goal. Now, if we come to the planning part, right? So in planning, the way this is what you see on the slide is a typical right, typical project which is composed of dependent tasks. That nothing new in that. The way we set this game up or the exercise up is that what we are doing is we are introducing the fact that there is uncertainty. I think there's somebody on not on mute. Do you want to go on mute? I can hear some background noise.
I will put that. Not one.
Yeah. So what we are doing in this particular exercise or game is that we have a set of resources who are supposed to execute each of the tasks, and we are introducing the uncertainty element in each of the tasks by asking that, let's say, for example, if each of us is given a dice and we have to commit that how many rolls will it take for me to get a 6 on the face of the dice, right? And we make it a little more interesting by saying that if you miss your commitment, whatever you have made, then you could be fired, right? So just to make it interesting. But main idea is to check with each of the task owners. So let's say there are 10 tasks in a particular project, and each of the tasks has a particular task owner. We're working with 10 people here. We say that, okay, now can you tell us that what are the number of roles which you are ready to commit, within which you're very confident that you will get a 6 on the face of the die, right? And then what we typically do is we go around playing just kind of have a trial round, and what you will find is that there'll be at least one person who will typically take anywhere upwards of 15 rolls to get a 6 on the face of the die, right? That is the probability. So I think I've got a quick graph or something like that, right? So if you see here on the x-axis, are you able to see the graph? Yeah,
Yes.
the
We can.
slide navigation work? Okay, great.
Yes,
So
yes.
on the x-axis, what you find are the number of rolls. You can equate it to number of days in for a project, and on the y-axis is the level of confidence or the probability with which you're looking for that number. So what typically happens is that if I right, we have made it interesting by saying your job is on the line. But in real world also, what you find is that people will be very, very careful when they give a particular time estimate for a task which they have to execute. Because again, if you go back to our first slide, people are involved, and people don't want to come across as somebody who gives a time and then is not able to meet it. If it happens once, twice, if you've got a good project manager, he'll excuse you. Third time it happens, you are taken to task. So we want to be very careful, and I think the more experienced we get, we are even more careful. So what will happen is that you will commit typically a time or in this example's case, you will commit that I will take 17 or 18 rolls to get a 6, right? Because that, if you mathematically work out, is with a 95% confidence level, I get something like 17 or 18 rolls to get a 6 on the face of the die, right? So now you imagine, once people have seen this, and you set up the game in this particular way, you will find that people will say, okay, if not 18, at least I need 15 rolls. Then I am comfortable that I will get 6 on the die. So you add up, and if it's just a simple linear project, you will find that you will have 15 into 10. So this entire project now has a 150 days kind of duration. And when you actually start playing, you will find that in most of the cases, because we know that there is actually with a 50 or 60% probability, you will find that most of the people will get a 6 on the face of the die within 4 or 5 rolls. But obviously, because we have set it up in a way saying that, right, I want whatever you give as the estimate is like a commitment from you. So people will give me 17, 18, and then we'll bargain and say, okay, let's crack a deal at 14 or 15. So with that, we have expanded the entire lead time of the project. And then when they actually play the game, they realize that, oh, actually, maybe there's only one person who actually needs help to kind of get over the line and complete it before before his whatever 12 or 14 or 15. Most of us have finished actually or completed the task in much shorter time frame, right? So then that opens up to the fact that, okay, do we really then need to look at trying to protect every task with safety? Because most of the times if you now translate it into a real project environment, what happens is, because people are involved, you will have 2 3 factors coming into picture. That once I have committed, let's say Vivek ji is my project manager, right, and I have committed 15 days to him, there's a very less chance that even if I finish earlier, I'll go back and tell him, sir, I have completed, I would like to move to another task. Because next time, right, if I when he comes back to me and if I tell him that, okay, again I'll take 15 days when last time I have done it in 5 days, right, they will not have a very friendly conversation, uh, because he will say, boss, you are giving 15 and completing in 5, do you know what you're doing? So I'll be very reluctant to report any early finish. Plus, all of us are, so what is called as Parkinson's law, right? That work expands to fill time. So I will keep on polishing, making sure that I end up at around 15 days. Second thing, what happens in reality, again, be mindful of the fact that people are involved here. Right? Because machine wouldn't have cared whether it was 5 days or 15 days, right? But people have their emotions, they have their egos, they have their appraisals. They're very important. Second thing is, all of us are students, right? So we get hit by the student syndrome, that I know that there's a high probability that I can do this in 5 6 days. So I'll probably hang around. And anyways, I'm operating in this environment of multitasking and this and that. So there's a good chance that I may not even start working on this task till about day 8, 9, 10, right? And then if the Murphy hits, because yes, there will be certain tasks which will take me 15, 16, 17 days. I don't know which task. It's a project environment. But now if this is the task which actually which faces that, I have actually lost all that safety, because whatever safety was there, I have, in some form or the other, I have wasted it. Right? So that is the injection, or that is the solution which we do in on the planning side in projects, where we say that, let me see if I can put a quick slide here. Yeah, so the direction of the solution is to now build a project network. So what we essentially do is, we say that whatever time you have given for each of the tasks, I'm just going to cut it into half, right? Why half? Why not 33%? Why not 60%? So in TOC, we have this thing of good enough, right? Simple and good enough. We just cut the individual task times by half, and half of that we put as project buffer. The main change in the mindset or the philosophy change here is that it is not important for us to finish every task on time. More importantly, we have to finish the project on time. And uncertainties will be there. So we are not saying that we are not taking out the fact that safety or buffer is required. But what we are essentially saying is that we will protect the project. We will not try to protect every task. Right? So this is how typically, let's say, a plan will look like in case of CCPM, where you will have, instead of 10, 10, 10 days or 15 days, whatever number we have bargained and agreed on, we will cut those durations, and we will line up uh, uh, a project buffer. If you have just kept it simple, so you have a project buffer. But if you have feeding paths, then you will have a feeding buffer. But essentially, idea being that let's protect the project, not each of the tasks, right? So then I remove all these issues of Parkinson law and student syndrome and all, because I don't have all that now. I just have to make sure that on a day-to-day basis, I'm reporting to my manager that, okay, I've started the task and I'm going to take so much more time to finish the task. And once I report that and I put it into my software, the software will tell me what is the health of the what is the health of the buffer. So we use this project buffer to give a signal. So I'll go to that slide quickly. Um, Yes, I'll skip this critical chain part. We'll cover this in our digital twin discussion. So what comes out here is, if you can see on the slide, what is called as a fever chart. So it's basically giving you a health status or update of the project based on that project buffer. And so this quickly tells you that how the project is progressing across weeks, right? So you can get a view of one project across the timeline of the project, or as in the next slide, I'll show you, if you're managing a portfolio of projects, you will quickly get to see what is the health of different projects and where do I need to focus. Because this is a typical issue. If you don't have a mechanism like this, it's difficult to figure out which project really needs the time of the senior folks, because everything seems to be important or nothing is important. So this mechanism gives us that. And what this does essentially is it calculates whatever is the percentage between how we are progressing on the project, which is the critical chain, and how my buffer is getting consumed. As long as that ratio is in sync, I'm okay. I know my project is progressing okay. As soon as that gets out of whack, that I'm consuming buffer at a higher rate than what I'm completing my critical chain or critical path, then there is a problem, right? And then there's an intervention which needs to happen. Okay, so I will just round this off. So again, this is like your different now projects which you can see. So I know that, okay, I know only P1, P2, P4, or P4 is actually complete. So P1 and P2 are actually the ones which need our attention. The rest of them are chugging along nicely. I don't need to really intervene unnecessarily. Right? So that's the fever chart part. So again, just to recap, and now the questions we'll take it up, otherwise we'll switch to digital twin. Is the just to summarize, right? So we said that the goal of the project is that we need to finish on time fast. For that, the constraint or where we need to focus is the critical path or critical chain, as we call it. And the major two problems or reasons why we waste time on the critical path is, one, from an execution point of view, we end up doing a lot of negative multitasking, which takes away a lot of time of the project. Projects are waiting, right, to start or waiting to complete, because you started some task and now it is hanging. There's nobody working on it, whereas our meter is running. So time in queue is increasing. If you see time in backlog, time in queue, time in process. So my time in queue is increasing when I do negative multitasking. Secondly, on the planning side, if we plan with this thing that, every task has to be completed on time, then my project will finish on time, I inadvertently end up creating an environment where the lead times are inflated. And after the lead times are inflated, because people are involved, and anybody who's involved, right? I mean, it's not you or me or anybody, anybody as a human being, they will react to how we are measured. So if you set up the environment in this particular way, you will find that again, lead times are getting elongated. And even though there's so much safety put in, we are wasting it, right? So we need to have counter mechanisms through critical chain to prevent this. So focus and finish and work as per this critical chain and the fever chart and those kind of mechanisms, right? So that's what I want to quickly share with you on the in terms of the concept of CCPM. Now we'll switch to I think the part which I think all of us are looking forward to, which is the digital twin. Okay, so just maybe take 2 minutes pause here, and then my colleague Shubham will start this discussion on digital twin, and then we'll do this together. But any questions so far, any observations which you have before we switch to digital twin?
So to understand, basically what you're telling is there are, let's say, 20 projects, and each normally people put a considerable buffer in each activity. So we crash those all activities and plan the project, and whatever the buffer is what we have crashed, we'll put at the end of the project, or
Correct.
some part of that at the end of the project.
Correct.
And when we do this, almost 80-90% projects are going in green.
Yeah.
Maybe 10-20% projects, like or 10% project may be in amber, which required a little attention with some intervention. They will be on time basically,
Yes.
and only maybe 5-10% of the project actually which get into trouble,
Yeah.
where the
Yeah.
strong attention is required.
Correct.
So there is for this 10%, there is no point delaying or taking too much time on 90% of the project.
Yeah. So even for this, so we'll show in the digital twin what are the different options. Even if you want to get all your projects to be delivered as per what you have planned, what are the different levers you have, right? Because right, if you don't have a mechanism like a digital twin, now you will see it.
Hmm.
I don't want to talk about it a lot right now, but you will see it
Yeah.
that you can play around with it and you can find out that okay, in your projects, if I apply this lever, right? If I add this specific resource here and deploy him on this particular project for one more week, I find
Hmm.
that my projects are coming back on track. So uh,
Okay. So let's discuss about digital twin,
yeah,
and then we will like
yeah,
probably have a discussion later.
yeah. So now I think Shubham, you can fire up our
I have
digital
a
twin.
question. Sorry.
Yes, yeah, go ahead.
Yeah, so if you're going to crush all the activities in half and put all of those time in buffers,
Yeah,
how will that work if your activities depends on resources that you need to plan? Because you typically need to estimate a time of completion because you need to let's say if you need to forecast an equipment, you need it by this time because by that certain time and one activity is done and one can begin. If you will crash this and put
yeah.
everything in buffer, then resources might not be ready and you will not be able to forecast them.
Yeah, so again, we'll show, we'll give you a glimpse of that in the digital twin. What really happens is that once you have, crashed the individual task times and you put it in the buffer, we also have a mechanism, what we call as staggering, right? So you will actually be able to figure out that, let's say you've got 10 projects. When do I actually have to release these projects? You can lay out these 10 projects. So if you use like a critical chain software, you'll actually be able to figure out that, okay, how are these projects actually going to get released and executed, say, over the next 6 months? And right, so you exactly know. And then if you look at it from a resource point of view, for example, that an architect or a developer, right, he will come across face to face with this project during this time frame, right? So that visibility is definitely there. It's not that we are running blind. That visibility is definitely there. Even if you crash the times, you still have a view of how my projects will be executed over the next 6 months or whatever time period, and how different resources will have to get attached to those projects over a period of time. The only reason why we are crashing the individual task times in the project is to make sure that the hypothesis is that there's a lot of safety in each of the tasks, which A, every task may not need, and B, if you put it, we'll waste it, right? So might as well have the buffer, because actually what we are doing by cutting by 50, 60, 50% of the, we are not actually taking away the time which is required to process or do that work. That still is available to the resource. What we are only stripping out is the safety or the buffer which is embedded within the task. Hmm.
Okay.
So, anyway, so if more clarity required, we can towards the back end of our
Yeah.
webinar we
We
can talk.
we
So I
can
think
discuss
Shubham,
after the digital twin, so that will give them
yeah,
better clarity actually.
yeah. So Shubham, I
Yeah.
think you can now fire up the digital twin. What we will do is what Shubham will do is
Mhm.
we'll first give you an overview of the different projects. Right, we are using some set of projects to show you the digital twin. So he will just take us through what are those projects, how number of projects, the different resources, how they are set up. And then what we'll do is we'll actually take you through four different scenarios. Again, connecting it back to what I talked about CCPM, the multitasking and the critical chain and all of that. So we'll take you through those four scenarios, and then time permitting, we can also show you what happens if you change specific parameter values. How does that impact our timelines and things like that? Huh? So that's the way we have structured it. So Shubham, I think if you can start.
Yes. I will be sharing my screen. Hope I'm audible.
Yeah, I can hear you very clearly.
Yeah.
Yes.
Okay, sure.
Yeah.
So, before directly like jumping into the digital twin, I will give you a background of what what kind of input we are giving to the digital twin. So to give a demo, we have used this condo construction projects, which has now kind of 10 tasks. Now on the screen, you can see there are these are the number of tasks which are there. These are the phases. For example, in design phase, there are these tasks which are there. In construction. So this is a simple project where there is design, construction, services and landscaping, and then finishing. So these are all the resources which will be required for this particular tasks, and and then this will be these are the dependencies, the predecessors which will be there, and these are the durations which are required for each and every task. These are the planned days, and as Aniruddha sir had also rightly mentioned, there is variability in this duration. So there will be some minimum likely time which this task will take. There will be some likely time, and then there will be maximum time which a particular task will take. So these are three different tasks, three different durations. And if we take now the critical path, what we typically do in projects, if we consider critical pathway, then we see that this goes up to 120 days. The whole project, the condo project goes up to 120 days, and the minimum duration in which we can complete is 60 days, and the maximum is 160 days. So in this way, this is the project. So using one of the critical chain software, I had plotted this a simple Gantt chart of critical path. This I had plotted, and then what we can see is now interestingly, this walls and roof structure and this task, the external walling, requires the same resource. Okay, and still we have considered them as parallelly starting. So they are running on parallel. So how is this possible? So what typically happens is that we don't consider the resource constraint in critical path, which we had previously discussed when we had committed 120 days to our customer. So we don't typically consider this kind of conflicts, resource contentions, which take place. So this is where the critical chain method comes into play. So what happens in critical chain is these are the walling contractors, and this is the duration. So what will happen is they won't run parallelly. These two tasks will run sequentially. After this task, only this task will go ahead. And so the critical chain, the actual duration which you should commit to the client should be 132 days. So this kind of critical chain method gives a good enough estimate which you can predict, which you can commit to the client. And there are, of course, lots of things like buffers and all, which I am not currently complicating here. But there are lots of things as well, which we can include in the critical chain method. So
yeah.
as we can see here, yeah.
Then show you complete this and I'll make a point.
Yeah, sure. After applying the critical chain, the volume contractor, after applying for each and every task, we can see that this task now is running sequentially. Previously, we had seen in the critical path method that they both are running parallelly, but as critical chain suggests that these two will have resource contention, and these two will then run sequentially. So then now for this particular simulation or digital twin,
Shubham, I'll just reiterate again. So this is one important difference between critical path and critical chain, right? That in critical chain, what we are recognizing is, or the way we are doing the whole planning is, we are not only taking into account the process dependencies that, for example, first design has to happen, then your maybe condo construction can start, so on, right? These are like process or structural dependencies, which you anyways recognize also in critical path. What critical chain brings in the element that there is, in most of the projects, there is a resource constraint. I don't have unlimited resources, especially critical resources, I have few. So in this case, let's say our walling contractor, I don't have enough resources that they can work on parallel on, even if by process wise I can do it, but I just don't have enough resources. So if in that case, if I do parallel, you will end up committing to the customer a timeline which you can never meet. On top of that, what you'll end up doing is if you open up both of these tasks now to the walling contractor simultaneously, right? Because he can do it from a process point of view, he can do it. If you do that, you will induce bad multitasking, right? So that is what critical chain prevents. First of all, it will give you a proper timeline because that is what it is. If you want to shrink this timeline, what you need to do, we'll see it in the twin. But this is the reality as it stands today. And then secondly, it will help you to prevent bad multitasking. Yeah, go on, Shubham.
Yeah, let me make it little put into context for the first simplification for the other
Yeah.
people.
Yeah.
If you are using like a tool like Microsoft Project, or which many people using, I'm not sure how many people will use this using with this critical chain project management, this tool. So, but by MS Project, many people using, maybe Primavera also. So when you get the critical path, and but you maybe these softwares highlight the resource over allocation, and when you label the resource and then you get the critical path, that is what the critical chain here is, right? Right. So once you
Yeah.
get the resource labeling and you get the critical path after that, that is called critical chain. Yeah, go ahead.
Yeah. Thank you.
Yeah,
Yeah. Go on,
thank
Shubham.
you. Yeah. So now, okay. So for this project, we have considered, now I had shown you one project, one condo project. So now to show you how the resource contention will be there, how different people like, how different tasks will be interrelated. So for that, we have used 10 condo projects, which will be running in parallel. And we have taken 5 different, now we have seen here, there are different teams which are going to work. Now, if you see in this screenshot, there are these different resources which are going to work. So now what we are assuming is there are 5 people each of these departments which we have available, and which will be working on these 10 different condo projects. So this is what we have planned to show you in the digital twin. And of course, there will be volatility, uncertainty, and everything, which of course a humanly brain can't imagine. There will be different n number of scenarios. So how to run this, how to kind of how confident we can be to estimate certain timeline. So now, as I had shown you, there are different durations. So how confident are you, and how will you commit to a certain time? So that is where our digital twin comes into picture. So now I will quickly jump into our digital twin. So this is the project digital twin, which now kind of to summarize what it does is it takes into consideration the time and budget commitments in real life conditions, and by changing certain rules, you can like directly view how the times how the due dates would change, how the financial conditions would be deteriorating or increasing. So everything you can see. Also, you can see the different bottleneck resources, the constraint, and if we add those constraint resources, and how it will impact our timelines and number of steps. So now getting into this, starting this thing. So just a minute, it takes some time to load.
So one thing I want to just share with all of us is that there are n number of settings and n number of rules and n number of parameters which are there, right? We have taken a small slice out of that and focus on that, right? But otherwise, we'll be here for next 5 hours. So
Hmm.
don't get
Yeah.
confused. You will see a lot of settings on the screen, but we'll just keep it on the few things which are important. Yeah, go ahead, Shubham.
Yeah. So as I said earlier, there I have imported 10 different projects of condos which are similar tasks, and the durations also similar for each and every task. So as we can see in this first box, the first quadrant, here we get the glimpse of what we have uploaded. There are 10 projects, and there are 4 phases per project. So there are total 40 projects with 110 total tasks and 9 different resource types. So now, if we start everything in parallel, all the projects in parallel, then it is estimated that the projects will get completed in 120 days. So it shows that if we start on 1st of April, then sorry, 4th of
4th
Jan,
of
then it will
Jan.
get so then it will get completed on 4th of May. So in this way, here it has been shown. And so similarly, in the second quadrant, we get the financial scene of the projects. So if you see, we had certain template where we can import the financial things as well. So we get to know that once if we complete all the 10 projects, then we will get this much of revenue. Then the variable cost will be this much. And overall, so the net profit would go up to $312K. So that is what we can see. And then the project plan summary. So basically from here, we can see the typically the Gantt chart, which I had shown earlier in a different software. So here also we will see the same thing, the Gantt chart. Okay. So here also, if we see, here, similarly, we can see a Gantt chart, but as we know, this is currently only in the first stage. So here it doesn't consider the resource contention. This is only the plan which we have uploaded. Still, we haven't run the digital twin. So it will show a simple critical path here for each and every, for the 10 projects, as I had mentioned, are running parallel. So if you go down, you can see the 10 projects are running parallelly everywhere. So now if we see in the last one, the fourth quadrant, so here we get the resource plan. So what are resources? What is the what are the number of resources which are available with us? So as I had mentioned, we have 5 resources each which are available with us, and then there are so this is the utilization, which currently, as per this the uploaded thing, what is the utilization which each and every resource is currently under, and this is what is the active utilization. So I'm not jumping into currently the formulas and all, so because it has some certain backend calculations. But if we see, the utilization is basically, it is the time required to complete a particular task divided by the total project duration. So it basically gives the utilization, and the active utilization is nothing but the actual time which it takes, and divided by the active time which is there. So there are certain calculations which are there. So based on that, it calculates for each and every thing, like for designer, what is the utilization currently, and for volume contractor as well. So this is the first screen which we get, basically a gist of what our projects are. And then moving on to the setup part now. So first we saw what our projects are. Now we will move on to the scenarios, as Aniruddha sir had mentioned in previously, that we are currently now considering 4 different scenarios to show you how the digital twin will work. Now in the first scenario, what we are considering is, we have taken that there will be multitasking. For sure, multitasking and Parkinson's law will always be there. So that is what we are considering in scenario 1. So in this is in scenario 2, what we are taking is, we are eliminating these two, the Parkinson's law, and we are removing the multitasking, and then we are checking how it will impact the project timeline and the financial things. So now the real thing comes in scenario 3, where we apply the CCPM part here. So don't get confused with all these different parameters. So there are lots of number of parameters. So just I will let you know what are the important ones. So this is the CCPM part in scenario 3, which we will be applying, and in which we will be seeing the results. And in scenario 4, we will typically see even after applying CCPM and after allowing different resources which are currently idle, if we allow them to work full time, like if they are sitting idle, then they should not be sitting idle. They should work on a particular task which is available. So if you allow that thing as well, then how the duration, how the timeline would get impacted in a positive. So that all things we will see one by one, the scenario by scenario. So next, let's run now the actual digital twin. So
Yeah. So just to summarize, so before you just hit the play button now, so just to summarize, these are the 10 projects, right? So condo, you can say villa, bungalow kind of, so real estate kind of projects we have taken. So 10 of them, you've got 5 teams. And what we have set it up is that one team will work on two villas or 2 condos simultaneously. We don't want them to stay idle, especially in the first scenario, right? And what we are then going to do is, the first scenario is going to be conventional, multitasking, all of that is going to be there. We'll see what outcomes happen. Then in scenario 2, as Shubham said, we are just stopped the multitasking, right? We are not allowing people the resources to multitask, that when they start a task, they must first finish it. In scenario 1, if you see, what we have done is, Shubham, can you just go back to the first screen if you can? What we have done is, we have set up in the scenario 1 the rule that after every 5 days, right, so this task switching frequency, now this is all configurable, right, that after every 5 days, the resource is supposed to move to the subsequent project, right? And what we are assuming here is that in this switching, he's going to have an additional time, or he's going to lose 20% of the time, because every time you switch, right? I mean, you can, I think, kind of relate to this, that when we are working in projects, if you have to switch every 5 days, you're switching, you do take some time, kind of a setup time, to go back to figure out what were you doing on that project 2 weeks prior to when you started. So there is that setup which we have done. Again, can you make 20%, 30%? It'll depend on the type of projects what you're doing. Right? So all of that is configurable. And then in scenario 2, what we are doing is, we're only switching off the multitasking, and the Parkinson law goes out. And then we'll run the scenario 3 and 4 and show you what happens now. right? What is the impact? Because the whole idea is that by just changing some rules, can we significantly improve the outcomes of the projects? That is the question we are trying to answer through this. Right? It's the same set of resources, same 10 condo projects, same 9 type of resources, 5 resources in every of each type, same 45 resources. Nothing else is changing in this. So now, Shubham, can you run? Then we can show the our friends how
Yeah.
it works out. So again, in this, there is perfect world and real world. Again, we don't want to confuse you with that. So we are not running the perfect world scenarios because in you have to one work in a real world where there is variability in task durations. We can't exactly predict. So they've given the option of that if you are working, want to check it out in the perfect world, what happens, right? So all of that is there. Yeah. So now we have run this in the real world across these 4 scenarios. So yeah, Shubham, you want to take up?
Yeah. So now, if we see, if we now here we see the fewer charts, which Aniruddha sir had also mentioned before. These are the 4 fewer charts which we see, and here we can see for each and every, for example, first scenario we have taken multitasking and Parkinson's law. So in this case, we see that actually the project gets completed on August 3. So average project duration is 183 days. But and so in the second scenario, if we see where we remove this multitasking in Parkinson's, so there is no multitasking. So in this scenario, what we see is the actual end date has drastically come down to June 20. So which we can clearly see that in CCPM also, in while applying this critical change, the first step is to eliminate this bad multitasking and Parkinson's law. So once after eliminating this thing, in the second scenario itself, we see a drastic reduction in the average project duration as well, and in the actual end date as well. So both these things we can see in the second scenario. In the third scenario, the change which we had made is we had just applied the CCPM part, the resource contention thing. So what happens here is there is again slight reduction in the this actual end date of the project, as we can see. And in the fourth scenario, where actually we pull out all the resources which are available and actually we equip them to do whatever task is available at their end. So once we implement this thing, we see that there is again a drastic improvement in the end date. So actually the end date is now May 24th, which was previously with multitasking and all, it was going up to some August 3rd. So now it is showing May 24th. So there is this drastic change here as well. So okay. Then now let's see quickly the due date part. So as I mentioned here also we can see that the target against the target how the actual date in date is improving scenario by scenario. But the interesting part here, one more thing which we can see is that the percentage project on time delivery, that is also improving significantly each and every project. Now we are not talking about the entire 10 projects, but if even if we consider the separate projects, still the percentage projects on time delivery is improving significantly as we move towards the CCPM and using all the available resources completely. So this is how the we can read it that the project on time delivery is improving significantly. So
So again,
then,
just to
yeah.
reiterate what we are saying, again, just to reiterate what we are saying is, right? So we started with all this saying that I want to finish my projects on time faster. And we launched these 10 condo projects, hoping that we have 120 days and there's enough buffer and all of that. And we'll be able to complete the projects by 4th of May. If you operate in the first scenario where you have multitasking and no CCPM, nothing like that, what the digital twin is telling us is that there is a very good chance that you'll actually end up finishing closer to the first week of August rather than the first week of May. So there's like a 3 months delay which will happen. And we can break it down. And if we go into the delays tab, we'll be able to see where is it that I'm getting hit. You will find that a lot of the time of the project is because the tasks are waiting in queue because we've not been able to right do the proper synchronization. People are moving from one task to the other, and that is creating all the bad multitasking and the time delay. So that is the base scenario. Now the point is, if we just put our execution policy, which I talked about earlier, of just preventing the multitasking and making sure that there's no Parkinson law, people are not people are not unnecessarily polishing things. you will suddenly find that there is a good reduction in the timelines. But still, it has not improved my on-time delivery because I'm still launching my projects at a go and I don't have control. I really don't know, how I should release the project. Going back to one of the questions which was asked, I think by Leandro, we don't have still that control in my environment, even in scenario two. That comes about in scenario three, because in scenario three, now I know exactly when I'm going to launch the project. And based on critical chain, and because of the fact that I've taken resource contention and all of that, I'm pretty confident about the date, what I commit to the customer. I'm pretty confident that I'll be able to meet it. And so in this particular scenario, my on-time project delivery, which was 0 or 10%, has now shot up to 60% because I've removed the multitasking part. I've removed the Parkinson law. I'm now planning as per critical chain. I'm staggering the release of my projects. I'm not unnecessarily opening up all the projects at one go. And in the fourth scenario, it is even more interesting that what I'm now doing is I'm actually making sure that I create conditions for resources to take up the work when it is available, in a way, increase the resource density on a particular task, and make sure that I finish off the task as fast as possible. And there again, we have given some settings. Again, it will change based on project to project. That it doesn't mean that if I change the number of people from 1 to 2, suddenly my time will go down by 100%. It will not happen that way. It will differ in every project to project. You can configure that. Here we have done some 33% and 40% and stuff like that. But the main idea being that suddenly in the fourth scenario, you will find now you've got excellent on-time delivery. You're able to meet what you've committed, and there's a crashing of the overall lead time from a portfolio duration point of view, from average project duration point of view, right? So that's what we wanted to show you. Maybe now, Shubham, should we go into the delays tab,
Yeah.
or you want to go into the financials part? Or yeah, can we quickly
Uh,
do the delays part and show up that time in backlog? And yeah, so if you can see here now in the graph, yeah, so we can look at it through numbers, or we can then later on look at it through the graph. So what you find here is across these four scenarios, S1, S2, S3, S4, right? As I said earlier, I introduced this concept of time in backlog plus time in process plus time in queue is equal to your total time in the system. So now if you see in scenario one, we are all over the place. There is no time in backlog because we're not holding back anything. We're just pushing the projects right out into the open. And your time in process is more or less around 120, 122 days across the entire project. What you are getting really hit by is the TIQ, which is the time in queue. So again, time in queue is broken into further parameters, which I'll not go into right now. What you now find in no multitasking, the second step is that your TIP has reduced to some extent, but not so much because we have taken out the Parkinson law. So you find some impact on some of the projects. Where you've got benefited is your TIQ has come down, time in queue has come down. So your overall time in the system has gone down, right? And that's where you're seeing that an average project duration earlier, which was 183 days, now has come to 142 days. So you're getting that benefit. In CCPM, again, as I said, uh, two things are happening. One is if you see now from project 6 to project 10, you have time in backlog, which is coming in, which was not there previously, because now you're holding back the projects. You're not releasing them at one go. You're going to stagger them, right? So you're getting some time is getting added there, but you find that your TIP and TIQ, time in process and time in queue, are coming down to some extent, and that's why your time in system is showing some improvement, but not a great deal. But what is helping you there is to get control in terms of commitments, on time delivery. And in S4, if you see, the major reduction which you are getting compared to S3 is your time in process has gone down, because now you've got higher resource density. Again, it is the same set of people, right? We are not increasing the number of resources. It's the same set of people, but we are creating conditions so that there's no hard allocation as such. If somebody is available, he can come together, work, and help to reduce the actual touch time or the process time. So a combination of all of these things, no multitasking, critical chain, and increasing the resource density is what is leading to suddenly from 183 days or completing the entire portfolio by 3rd of August, we are suddenly finding that now we are coming closer to our some imaginary date which we had said we thought everything will be done by 4th of May. We have now at least got to 24th of May. Right? Now, suppose further we want to bring it down. If we have time permitting, we'll go into that discussion. But this is what the whole thing is, right? So you must understand where is it that I'm losing time, and what change of rule will impact what component of the lead time. Will it be time in queue? Will it be time in process? Will it be time in backlog? Shubham, we can quickly show the financials part because it's not just about time.
Yeah.
We need to also, yeah. So you can take that financials part.
Okay. So in this screen, we can also see the financial part as well, the comparison as well. For example, in scenario one, what all where the revenue will almost, of course, remain the same because all the projects are getting completed on time, then they will get the revenue. But the variable cost would keep on changing as we move on from one scenario to another till the end. And if you see the net profit, to sum up, if you see the net profit here, in case of multitasking, it's quite low, the net profit. And as we move towards the CCPM scenario, we see that because this operating expenses, because we are now avoiding multitasking, because we are now saving on time, and also because of that, the net profit is now going around from minus 402K to it is almost coming to somewhere 150, 153K. So that is the power of how the financials will also get impacted using this thing. So
Yeah. So if you see, just to just reiterate what Shubham said, right? So we started with this dream that we'll end up with around nice 26% margin,
yeah,
312, right? But really, what in reality, what you find is if you operate conventionally, you will not only not make that 312, you'll actually end up with a loss. Because the way this thing has been set up is that you have certain penalties if you don't finish on time. And this is not uncommon, right? There are projects where penalties have to be paid if you don't finish the projects on time. So what you're finding really is your financials have completely gone out of the window, right? You have ended up with actually a loss. And this lost sales means that because you took so much more time to just finish these projects, you could have, completed, many more other projects and booked your revenue, which you're not able to do. But as you go forward here, in no multitasking, your loss comes down, and then you turn around the corner in CCPM, and then you really rocket when it comes to the extra resources wala thing. But now, if you have to get to 312, what do we do? Maybe we don't have the time today, but you can again play around. See, the whole idea of this digital twin is that before you launch something like this in your real environment, you can actually play around and see my business, because again these are just 10 condo projects, some demo projects which we have taken just to show you the whole thing. But the idea would be that if you are interested, we would be happy to engage with the company and do a free simulation for you, because we feel that this right, because CCPM and these concepts are counterintuitive. So even though I might give you some games and exercises and slides, the real power is if you can actually put the projects here and play around with the rules and see, okay, what are those set of rules which are really going to bring the benefit to me from a time point of view, from financials point of view. That is what I think will help you to adopt kind of a variant of CCPM which is relevant for your particular company and your set of projects. Okay, so
yeah.
I think maybe we'll just take last 2 minutes on the digital twin. Anything else, Shubham, you want to show quickly?
No, the one screen I would like to show of the scenario comparison,
Yeah,
which
okay.
so
Yeah, so here
now
in this
here
screen, we
we
are able to do more replications, right? Because so that the randomness goes out. Yeah. So Shubham, continue.
no, so here actually we are doing this 100 iterations because the as sir was mentioning, the randomness will go out and we can see the results in a single screen. So if we run all the scenarios in this screen, then we will get all these things. Now, what all things we had discussed about this project completion on time, average cost per project, the revenue, the penalties, what all will be incurred for each and every scenario. So everything we will get to see in a go. So this is currently this is in progress. So once this completes, we will see each and everything in a single go. So that's what I wanted to show you all
Very, very
to
good. Yeah.
conclude.
Right. So the operational performance and the financial performance, all you get to see in one screen, right? The operational is the
Yeah.
top part, which is the portfolio duration, end date, due date, blah, blah, blah. And then the financial part is your revenue, cost, penalty. So all at one shot, you can see, okay, this is what I decided. Now this is what I'm getting in terms of, then you play around with it. Yeah. So I think in the interest of time, I think Shubham will pause now
Yeah,
and
yes.
take up questions because we have kind of got towards closer to
Yeah.
8:30. So, Vivekji, over to you. And is there any questions?
Yeah, so let's check if people have any questions. Anybody has any questions? No questions?
Sir, in this CCPM, we are running different scenarios.
Yes.
So that initially we must have those kind of data which is to be planned, and accordingly we are going to have that results which is being obtained, right?
Yes. Yes.
Yeah.
Yeah.
So again,
We
from
need
the
to.
history or
Yeah.
maybe similar kind of things, we have to have that idea in mind. What are we planning well in ahead, and then what are the results which we will be going to get it.
True. So for the digital twin, if you're saying from a digital twin context point of view, there is a template which is there where like a work breakdown structure, we need to, from a MPP or whatever tool you're using, we need to have those set of projects. Let's say you have 10 projects which are running. We need those, tasks, dependencies, resources, blah, blah, blah. If you want a financial perspective, then some financial data about the projects. So we have a template for that. And then we upload that into the twin and then we run it to see how the different tools could impact the project outcomes.
Okay, so student or many of our MTech project management students, they have joined for this today's seminar. So they
Okay.
might have seen this particular how the tools are operating and the requirement in real life scenarios.
Yeah.
So really worthwhile to hear you, sir, and it was interesting. As a
Yeah.
coordinator of this particular project management from COEP side, I take this opportunity. So it was excellent session, sir. And if some students they are having any queries or any question, please raise.
Or we can see that also, like for sir, like at COEP, if Aniruddha, you have some time, some time, probably we can demonstrate to to the students as some simulation sometime at COEP.
Yeah, happy to do that. Happy to. The way so the questions, happy to take it. I'm just filling in a little bit of time. But the idea is that, see, these counterintuitive concepts like CCPM, what we have found is that the adoption in the industry is still, is still work in progress. And what I find is that these tools like digital twin and simulation will go a long way in helping companies to understand really how this will impact their set of projects and their business. Because like you have in R&D, you have before you launch a car, you do so many simulations, virtual in the virtual environment. I think you don't launch a car, right? You test out so many things through your digital tools. This is an attempt by Goldratt Labs. So the company which has developed this product comes from Goldratt Labs, and they have taken up this initiative that we must come out with these twins and simulations so that we can take this message across to the industry and companies that this methodology is powerful, and we as practitioners also know exactly what rules are going to work the most are going to be the most effective in a particular environment, right? Because otherwise just reading a book like the Goal, or there's another book called Critical Chain, you pick it up, you can't implement it. It's,
Yeah,
every
definitely it
environment has
requires
its
assistance actually.
nuances. Yeah.
It requires assistance, and let's like all professional on the ground have a lot of work to do. For them, it is a very little time for having an additional taking additional pain to do all these things. So they definitely external help is necessary to find out that how you can really save your time, or at least which with what scenario will work for you actually.
Correct.
Figure it
Correct.
out which is the most optimum way to go ahead as such.
Correct.
Very good.
Yeah. So we can take up questions if there are any.
Yeah, so I'm just seeing if anybody has any questions. So far, I don't see in the chat.
Okay.
And, okay, so Okay, so he's saying great tools give you different scenario. Yeah, so tools is good, and but as you need some data actually to really use especially in the simulation.
Yep.
So, but it also the kind of amount I think of work you invest in getting data, you save much more than that actually out of this as such.
Yeah.
So it's worth like gathering data and doing an analysis.
Typically, if you see every organization, I mean, a reasonably good project management organization will have a project plan. Right? And
Right.
a project plan will have task dependencies, durations, resources, right? That mapping is typically there. That's what we need essentially for the digital twin.
True, 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 true. Good.
Okay. So, anyways, I think maybe people can digest
Right.
what we have shared. My email IDs are anyways there, I think, with you. I can again fire up and show it. Let me just
Yeah, you can
minute.
probably put your contact in the chat actually.
So I will do that.
Yeah, or you can put it to the chat also. It will be much easier
Yeah,
to
I'll do that.
capture it actually. Yeah. Okay, so it's really nice. Sir, so let's move on to close it. And
Yeah.
sir, आप लेंगे?
I think there's one question. Good evening. Can you please guide us the working portfolio in robotics?
Can you please guide us the working portfolio of digital twin and robotics with the help of AI while using ROS, and what is the better for digital twin, which is ROS or ROS2?
Sorry, this is out of syllabus for me. I have no clue.
Okay, I didn't understand. What is ROS?
No,
So I
it
have
may
no clue.
be ROS,
Aditya?
robot operating system. He was
Robot operating system.
memory.
Okay, okay, okay,
No,
okay.
in general, whenever we are making that equipments and we are making that physical models, and then same thing it should behave. So that he wanted to analyze as a part of digital twin concept. Means machine whenever we are going to have with the same kind of sensors and actuators and all, it will be behaving and we are going to get the expected results out of it. But in our this project management, whatever sir is suggesting as a twin, digital twin, that means we are simulating in the similar environment kind of thing without, means we are assuming that it is a set which has been fixed, and accordingly if we are varying it, how it will be behaving and getting the results out of it. So it is in that way a digital twin concept which is being used,
Yeah,
I think.
absolutely.
But I think if we look into this, I feel there will be some applicability here also. I feel so in the robot scenario also. Okay, which combination actually will work better?
Yep.
Good, good. So I think we are reaching to our time. So thank you very much, and I really appreciate you have put up a lot of efforts in explaining the general understanding of project management, and then the critical chain project management, and then how we are applying the digital twin, basically how we can simulate the various scenario in future which is going to happen, and finding out that which one is best, not only delivering faster or on commitment, and also saving a lot of money as such on that. So I think it's to me it looks very impressive, and we look forward for that opportunity where we can apply this. And
Sure.
I feel in the especially I see in the manufacturing industry where a lot of R&Ds are happening. R&D projects are generally very uncertain in general. So there is a very good applicability. In the construction project also, as you have taken the examples, it's very much applicability. However, my hope is little less on the construction side, because the applicable applications of project management and processes is little poor on the in the construction project, where I feel it is the most required actually. However, the adaptability is quite less as such. But I think that there are people who may be trying it out, and that's really nice. So thank you very much, Aniruddha. and for demonstrating, and thank you to Shubham as well for running this simulation, and thank you to all the audience.